Let's look at an example of a type of thing that might need to be done on a computer or a type of way that things might need to be stored on a computer and try to think about how it would need particular data structures or particular behaviors to fit it. For example, the directories on a computer where files are stored. We've got a directory layout here where there's the home directory. It contains some subdirectories, and then they contain either files or subdirectories of their own that might have files within those as well. So I want to think about if we opened a terminal, if we opened a file navigator or anything like that at this home directory, what would we have to do to get to this specific family picture down here? What would be the steps needed? What would that tell us about the structure of the data in this case? So, as we do, pause for a moment and think about it. Pause the video, think about what the steps are and what that implies about the structure of the data. Pause it. What I hope you noticed in thinking about that is that to get to anything inside of this directory structure, we have to start from the home directory. Then we have to tell it another directory to follow through to, and we may have to tell it yet another directory. In this case, we do have to tell it the vacation directory next, and then we finally arrive at our file. And so it takes steps from one to another that we can tell it, okay, from home, go to pictures, go to vacation 2012, and then look at that picture that's in there. And this kind of structure has some relationships built into it, right? We know that these directories, documents, desktop, and pictures are subdirectories of home. That's a relationship between them. It's also possible to think of it as a hierarchy, that the home is the outer directory and these are inner, smaller directories, similar to how a business might have departments within that business, and it may have teams within those departments. There's a hierarchy to them. There would be a leader of the entire business, the CEO. There would be a leader of those different departments, department heads, and there would be leaders of those different teams of people as well. And so there's another sort of hierarchy that we are commonly thinking about in our society built into that. So when we need to represent this kind of hierarchical data or this data with relationships like these, we will often use the data structure of a tree. Because if you look at the data that's set out here, those directories and their files, it doesn't fit nicely into those linear data structures we've seen so far. An array is just one row, and there's no row to this. We could have home, documents, and its sub things maybe as one row, but we still wouldn't know where home ends and documents begins if there were some files that lived in home. If we include the other directories, it would be very difficult to know where documents ends and desktop follows. Is desktop a subfolder of documents, or is desktop a subfolder of home? Those kinds of relationships don't lay out linearly very well, like an array or a linked list would allow us to do so far. Even a map doesn't inherently have a nice structure to it like this, that we could represent this. So trees allow that. Trees are building on this idea that you will have some starting place that will allow you to step forward to some other places like these subdirectories, and those will allow you possibly to step forward more. And at some point, you're going to hit an end to them where you can't step forward any further. And there may be interesting things or data there. There may be interesting things or data all along the process at each of these as well. So I've started to represent this for you as a node class that works for a tree versus, say, our linked list node that had a next and a previous. Our tree nodes might have an array of children because they could have any number of things connected to them, so that our home directory would have 3 children, documents, desktop, and pictures. And then those could have their own children. Documents could have report and lab 3, and so on. And it would branch all the way through like a tree. Some trees don't have an array of children. Some trees will have a limited number of children. For example, we might have a private node left and right. Some trees will have sort of a concept of 2 children. It's up to the design of the specific tree whether it has an unlimited number of children in some sort of array or array list, or whether it has only a couple of children, or that sort of thing. But you can see how this could allow us to represent things like a family history of grandparents and their children and their children's children and so on. It could allow us to represent a university where UNH is the first node, and then the College of Engineering and Physical Sciences is a child node of that, and the other colleges, College of Liberal Arts and so on, are all children of it. And then they have their departments within those, which are children of the colleges. So this opens up possibilities for us to represent structures and relationships and hierarchies that can't easily be laid out flat like an array or a linked list can. And so you're going to learn about some of these different structures within a tree, like the nodes, which represent one piece, one level, one name, one person inside of that tree. They have edges between them when we talk about them theoretically, and those edges are just the connections. You can envision a drawing where home is the top, and then we draw a line from it to documents, and from it to desktop, and from it to pictures. Those are the edges. The edges are the ability to get from one to another. And in code, we don't actually write those edges typically. Those are just the variables. Those are the connections, like a node having a left child or a right child, or having some set of children. There's a connection between each of those, and it's done in code by the variables. And you'll look at some other concepts of what the root of a tree looks like, the leaves, and so on, and that will prepare us to move on to looking at more specific tree data structures that give us even more specific functionality and even sometimes better performance than we might be able to get with a linked list or an array. So you'll see those as you look at sections A and B of the Tree 1 activity.